Hello, grade 9 students. How are you today? Hope you're doing great. Welcome to our session for this week, wherein we are going to distinguish the different types of compounds based on their properties. Have you experienced placing white sugar and table salt side by side? How did you distinguish the two? There is a wide variety of compounds and most of them look physically the same, like table salt and white sugar. And it would be easy to determine these two substances by tasting them. But this method of identifying substances is not always applicable since some of them can be toxic. You have learned from your previous science classes that compounds are formed between the chemical combinations of two or more elements. And there are two common types of compounds based on their chemical bonding characteristics. We have the ionic and covalent compounds. We will learn more about this after the music break. Don't go away!
Tayo na't pa rin ang mundo ng siyensya, tumuklas ng kaalaman sa hayop at halaman, kalawakan, kalupaan, katubig at kalangitan. Di ka may iwan sa pag-aaral ng hanggang mag-eksperimento ng mga bagay para sa bayan ay aagapay. Ikaw ang batang scientist, ikaw ang batang scientist, ang pag-asa ng bayan. Ikaw ang batang scientist, ikaw ang batang scientist, ang pag-asa ng bayan.
Welcome back! And now, let us differentiate ionic from covalent compound. An ionic compound is a combination of a metal and a non-metal element, whereas a covalent compound is a combination of two non-metals or a non-metal and a metalloid. And to determine whether an element is a metal, non-metal or metalloid, you may refer to your periodic table of elements. The pink squares are metals, the blue ones are non-metals, and the green ones are metalloids. As you can see, most of the elements are metals and are placed on the left side of the periodic table, except for hydrogen. On the right side are the non-metals separated by a stair-like pattern, which are the metalloids. Now let us take up the ionic compound. This is, as we have said, formed by a metal and a non-metal element, and the chemical combination between these two types of elements result from the formation of ionic bond between atoms. Ionic bonds are electrostatic force of attraction that holds cations, which are the positively charged atoms, and anions, which are the negatively charged atoms, together. Sodium chloride or table salt is an example of ionic compound. It is a combination of sodium, which is a metal, and chlorine, which is a non-metal. Sodium becomes a cation with a positively charged atom as it loses an electron and transfers to the chlorine atom. Chlorine, gaining the electron, becomes an anion with negatively charged atoms, and eventually an ionic bond is formed. And here are some examples of common ionic compounds and their uses. Sodium bicarbonate, or what we commonly call the baking soda, is used in baking and as an antacid to reduce stomach acid. It can also be used as treatment for indigestion and upset stomach. Sodium hydroxide, on the other hand, is used as a cleaning agent and as a component of soap and detergents. Now let us move on to covalent compounds. Covalent compounds are substances that are formed from a chemical combination of two or more non-metal elements, and this could be between a non-metal and another non-metal or a non-metal and a metalloid. Atoms of the different elements are held together in molecules by covalent bonds. Unlike ionic bonds, where electrons transfer from one atom to another, covalent bonds share their valence electrons. Force of attraction between the shared electrons and the positive nuclei of both atoms hold the atoms together in a molecule, which is the smallest particle of a covalent compound that still has the properties of the compound. Table sugar or sucrose is an example of a covalent compound. It is a combination of carbon, hydrogen, and oxygen atoms. Another example of a covalent bond is water, which is a combination of hydrogen and oxygen. Hydrogen and oxygen atoms share electrons to form a water molecule. This sharing of electrons results to covalent bonds between atoms. Now let's have some examples of covalent bond and their uses. Carbon dioxide in liquid or solid form is used as a refrigerant in fire extinguishers. It is also an essential gas for plant and animal processes. But its excessive amount in the atmosphere is unsafe because it contributes to global warming. Now let us go back. When table salt and white sugar are placed side by side, they may appear the same because they are both white crystalline solids. We all know that table salt tastes salty and sugar tastes sweet. This property suggests that they are very different substances. Aside from their tastes, how are sugar and salt different? More specifically, how are covalent and ionic compounds differ from each other? The ionic bond formed between the cations and anions is very strong, and these ions are arranged in a regular geometric structure called crystal lattice. Different ionic compounds have different crystal forms. Ionic compounds have a very high melting and boiling point. The ions in a crystal lattice are closely packed together, creating a small electrostatic force of attraction between them. And the more ions there are in a crystal structure, the stronger the ionic bond. Therefore, a large amount of energy is required to overcome these bonds. Table salt, for example, melts at 801 degrees Celsius and boils at 1413 degrees Celsius. Furthermore, ionic compounds are also good conductors of electricity. Ionic compounds are hard and difficult to separate because of their strong electrostatic attraction between ions. Now let us move on to the properties of covalent compounds. The covalent bonds between atoms are quite strong, but the intermolecular forces between them could be relatively weak. The addition of a small amount of energy separates these molecules easily. Therefore, they have low melting and boiling point. In addition, covalent bonds are relatively flexible and easy to break, which causes molecular compounds to form gases, liquids, and some solids at room temperature. Furthermore, covalent compounds tend to be more flammable than ionic compounds. Combustion is a reaction that releases energy when the compound reacts with oxygen to produce carbon dioxide, and water. Covalent compounds separate into molecules when dissolved in water, so they typically do not conduct electricity. Covalent compounds can be polar or non-polar. The polarity of molecules results from the differences in the electronegativity of the bonded atoms. Electronegativity is the ability of an atom in a molecule to attract shared electrons towards it. The greater the electronegativity of an atom, the stronger is its ability to attract shared electrons towards itself and away from the less electronegative atom. And the electrons are not shared equally, and a part of a molecule carries a partial positive charge, while the other part carries a slight negative charge, creating a dipole. To determine if the type of bond is polar or non-polar, one has to consider the electronegative difference between the bonded atoms. The greater the difference, the more polar is the bond. And if the difference in electronegativity is greater than or equal to 2, the electrons are completely transferred instead of being shared. And an ionic bond will be formed rather than a covalent bond. To summarize what we have learned, ionic compounds have high melting and boiling points, while covalent compounds are opposite. Ionic compounds are hard and brittle, while covalent compounds are soft and flexible. Ionic compounds conduct electricity in aqueous form but not in solid form, while covalent compounds do not conduct electricity at all. Ionic compounds form crystals. Covalent bonds are flammable and can be classified as polar and non-polar. And that's all for now, my dear grade 9 students. We will be discussing about the formation of ions in our next session. But before we end up, let me leave you this message from John Wooden, and I shall quote, "Do not let what you cannot do interfere with what you can do." So once again guys, this is Teacher Maribel saying stay safe and God bless.